On behalf of the Department of Mechanical Engineering, KIPM College of Engineering and Technology, it gives me immense pleasure to extend a warm welcome to all of you to the inaugural session of the Faculty Development Program with title Towards Sustainability, the Role of Advanced Materials in Next Gen Engineering, which is scheduled for today, the 13th of October 2025. This gathering marks an important step towards fostering academic growth, professional development, and knowledge sharing in the field, which is pivotal for our collective future. We are truly delighted to see such a distinguished audience comprising academicians, researchers, and faculty members from various institutions who have taken the time to join us today. Your presence here signifies your commitment to continuous learning and the dedication to advancing knowledge in your respective areas of expertise. We are deeply honored to have among us our esteemed chief guest, Professor Om Prakash sir from NIT Patna, Mechanical Engineering Department. Om Prakash sir is a luminary in the field of sustainable energy, and his contributions to research on clean energy technologies, environmental impact assessments, and renewable materials have widely recognized both nationally and internationally. His extensive research and pioneering work in sustainable energy makes him the invaluable source of insight for all of us today. We are indeed privileged that he has graciously accepted our invitation and taken the time to share his knowledge and blessings and perspectives with us during this FTP. His presence today will undoubtedly inspire and motivate us to further explore the critical challenges and innovative solutions in the domain of clean energy and sustainability. And I also express my very warm welcome to our respected director, Mohammad Zahir Riaz Khan, sir. In his visionary leadership, KIPM College of Engineering and Technology has consistently strived for excellence in education, research, and innovation. His guidance has fostered a culture of academic rigor, collaborative learning, and holistic development for both students as well as the faculty members. We are fortunate to have here in the session our respected Managing Director, Shri Binod Singh, sir, and our Honorable respected Chairman, sir, Shri R.D. Singh, sir. And we are so fortunate to have such leaders whose commitment to quality education and progressive thinking continues to steer our institution toward higher achievements and global recognition. The Faculty Development Program is being inaugurated today, which is designed with a clear objective to promote the exchange of knowledge, enhance teaching and research capabilities, and broaden our understanding of the environmental impact and life cycle assessment of the clean energy materials and the sustainable replacements. In the current global context, where energy sustainability and environmental responsibility have become crucial, this program holds immense relevance. So it aims to provide the participants with insights to the sustainable alternatives as well to conventional energy systems and encourage innovative thinking in energy engineering solutions and emphasize the importance of integrating environmental consideration into technological developments. So I would like to take this opportunity to extend my heartfelt gratitude to all the participants, resource person, and organizing members whose efforts have made this event possible. Your enthusiasm, dedication, and collaborative spirit are what transform such programs into meaningful and impactful learning experiences. I am very confident that over the course of this FDP, through this week, we will engage in fruitful discussions, gain valuable knowledge, and emerge better equipped to the contribute positively to the field of sustainable energy and engineering education. Once again, a warm welcome to everyone present. Let us together look forward to a stimulating and enlightening program ahead, which is filled with learning, collaboration, and inspiration. May this FDP serve as a platform for knowledge sharing, personal growth, and the advancement of sustainable engineering practices. So, to initiate the inauguration program, I request now formally to commence the proceeding for this inaugural session. I request and invite Dr. Shah Fateh Azam sir, Head of Department of Mechanical Engineering, KIPM Technical Campus, to kindly deliver the welcome address and extend a warm welcome to all the dignitaries and participants present here. Sir, please.
Okay. Good evening and a very warm welcome to all. On the behalf of Department of On the behalf of the Department of Mechanical Engineering, KIPM College of Engineering and Technology, Gorakhpur, it gives me immense pleasure to extend my heartfelt greeting to everyone gathered here for the inaugural ceremony of the AICT Training and Learning ATAL Academic Faculty Development Program on the theme of Towards Sustainability, the role of advanced material in next generation engineering under the sub-thrust area of advanced function material. At the outset, I take this opportunity to express our sincere gratitude to the All India Council for Technical Education and the ATAL Academic for sponsoring and supporting this FDP. Their consistent effort to the enhance faculty competence and promote research-based learning and have been instrumental in advancing technical education across the country. We are grateful to our respected Chief Patrons, Professor J.P. Pandey sir, Honorable Vice Chancellor, Dr. APJ Abdul Kalam Technical University, Lucknow, whose visionary leadership continue to guide academic excellence, and also a warm welcome to the esteemed patron, Engineer R.D. Singh sir, Chairman, KIPM Technical Campus, whose consent, encouragement, and support make such initiative possible. And MD sir, a very special welcome to our chairperson, Dr. Mohammad Zahid Riaz Khan sir, director of our institution, whose dynamic leadership and guidance have always been a source of inspiration of all of us. I would also like to warmly welcome our distinguished resource person for today's session, Professor Om Prakash sir from NIT Patna and Professor Mohammad Zahir Khan Yusuf Zai from IIT BHU Banarsi, who will be leading a technical session during this FDP. The theme of this program, Towards Sensibility, the role of advanced material in the next generation engineering, in both timely and significant, as the world transition towards cleaner technology and sustainable practices, the role of engineers become increasingly vital. This FDP aims to provide participants with a comprehensive understanding of advanced functional material, their life cycle assessment, and their environmental impact, thereby bridging the gap between innovation and sustainability. At KIPM, we firmly believe that a comprehensive education goes beyond the technical skill. It nurtures intellectual, moral, and ethics value. Our lush green campus, state of art in infrastructure, and dedicated faculty create an environment conducive to learn research and holistic development. The Department of Mechanical Engineering, in particular, strives to blend strong theoretical foundation with practical exposure, preparing students and faculty like to address real-world challenging. I also extended my heartfelt appreciation to the FDP coordinator, Mr. Rahul Patel, and all organizing members whose untiring effort have made this program possible. Once again, I welcome all dignitaries, streamy speaker, participants, and faculty to this enriching academic event. I am confident that the coming days will offer valuable learning, experience, inspiring discussion, and opportunities for collaboration. Thanks to all, and I wish to program grand success.
Thank you very much, sir. Now, to give us an overview of the faculty development program and to share the purpose and the planned activities of this academic initiative, may I now invite Mr. Rahul Patel, Assistant Professor and Faculty Development Program Coordinator, to address the gathering. Sir, I request you to enlighten us with the details of the FDP. The platform is yours.
Good evening, everyone. Respected Chairman, sir, respected Chief Guest, sir, Director, sir, esteemed guest, and dear participant, a very warm welcome to all. I am Rahul Patel, Assistant Professor in the Department of Mechanical Engineering and Coordinator of this AICT-sponsored one-week Faculty Development Program on Towards Sustainability, the role of advanced material in next generation engineering, organized by the Department of Mechanical Engineering, KIPM College of Engineering and Technology, Gorakhpur. This FDP schedule from 30th October to 80th October 2025 aims to explore how advanced and functional material can drive innovation and sustainability in modern engineering. With growing environmental concern and the global shift towards green technologies, understanding materials that are efficient, eco-friendly, and sustainable has become crucial for next generation engineering and research. We are privileged to have a rich lineup of speakers from IITs, NITs, and leading industries, along with overseas experts in line with the ATAL guideline that emphasize at least 50% experts from the industries. Their collective experience will certainly enrich our understanding of next generation engineering solutions. I sincerely thank AICT and ATAL Academy for providing this wonderful platform and express my gratitude to our chairman, sir, MD, sir, director, sir, and head of department for their guidance and support and my organizing team for their effort in planning this program. My heartfelt appreciation also goes to all speakers and participants who have joined us from different parts of country. To all participants, I extended a heartful welcome and encourage you to engage actively throughout the week. I hope the FDP becomes a meaningful learning experience and inspire us all to integrate sustainable into our teaching, research, and innovation. Thank you, and I wish the program grand success. Thank you.
Thank you very much, sir. Now, to mark the formal inauguration of this faculty development program, I now invite our respected director, Dr. Muhammad Zahid Riaz Khan, sir, to deliver the inaugural address. Sir, I truly privileged to have your inspiring presence with us today, and I request you to kindly share your thoughts and insight with all of us. Thank you, sir.
Thank you, Anuj. Good evening to one and all present over here. Honorable Chief Guest of today's inaugural session of 5-day FDP program and the guest speaker of the today's session, Professor Om Prakash sir, respected Professor Om Prakash sir, and the second guest speaker, respected Professor Mohammad Zahir Khan Yusuf Jai sir, Honorable Chairman sir of KIPM Technical Campus, respected Managing Director sir, all the faculty members, head of the departments, participants for the 5-day FDP program. On the behalf of KIPM College of Engineering and Technology, I warmly welcome you all in this 5-day faculty development program sponsored by ATAL AICT Training and Learning Academy on the highly relevant and futuristic theme towards sustainability, the role of advanced material in the next generation engineering. We stand today at the defining juncture in human progress, a time when the traditional paradigm of the industrial growth and the material utilization must evolve towards sustainability, energy efficiency, and environmental responsibility. The journey towards sustainability is driven by innovation and advanced material from the of its new from its new era of the responsible and realistic engineering. The faculty development program has been carefully designed to provide comprehensive exploration of next generation material and technology that are transforming multiple domains of engineering. Over the coming days, our distinguished resource person will lead deliberation on the diverse and emerging themes from clean energy and life cycle assessment to advancement in automotive sector, nuclear and photovoltaic technology, along with the integration of sustainable material like bamboo and other and the reutilization of industrial waste in cement manufacturing. I firmly believe that the true success of any faculty development program lies not only in the knowledge it imparts, but also the curiosity it ignites and the collaboration it cultivates. This platform will undoubtedly serve a vibrant space for sharing ideas, nurturing research, and promoting pedagogy initiatives that align with the nation vision of the Atmanirbhar Bharat and the United Nations Sustainable Development Goals. I take this opportunity to express my sincere appreciation to the AICT ATAL Academy for their consistent efforts in empowering faculty across the nation that's through such transformative initiatives. My heartily congratulations to the organizing team, especially Mr. Rahul Patel, the coordinator of this FDP program coordinators and resource person from the eminent resource person from the various IITs, NITs, and industries for such a rich and multidimensional academic program. I also thankful to the management, especially our mentor, Honorable Chairman Sir, for motivating, always motivating us for this type of programs. I'm very thankful to you, sir. Let us utilize this week to reflect, learn, and innovate, ensuring that technologies and material we develop today contribute to the cleaner, greener, and more sustainable tomorrow. Once again, I warmly welcome you all to this faculty development program and wish it great success. Thank you. Jai Hind.
Thank you very much, sir. Now, I would like to invite our Managing Director of the Institute, Sri Vinod Singh sir, to address the audience and bless us with his encouraging words. Sir.
Respected Chief Guest, Professor OP Sir, respected Chairman, KIPM Technical Campus Sir, Director Sir, HOD, all faculty members. सबसे पहले तो हम AICT द्वारा फंडेड अटल FDP प्रोग्राम को कराने के लिए हम AICT को बहुत बहुत शुभकामना देना चाहते हैं। कितना सुंदर प्रोग्राम ऑर्गेनाइज कर रही है, इससे हमारे फैकल्टी मेंबर्स और विद्यार्थियों को बहुत ही लाभ मिलेगा। ये पूरे दुनिया का आज का ये बर्निंग विषय बन चुका है सस्टेनेबल एनर्जी डेवलपमेंट के लिए, जीरो वेस्ट मैनेजमेंट के लिए। आज पूरा विश्व, यूनाइटेड नेशन ऑर्गेनाइजेशन, उसके विशिष्ट सहयोगी संस्थान, जलवायु संगठन, विश्व पर्यावरण संगठन, चाहे यूनेस्को हो, विश्व स्वास्थ्य संगठन के सारे लोग इसके लिए प्रयास कर रहे हैं कि एनर्जी को सस्टेनेबल डेवलपमेंट के क्षेत्र में कैसे काम किया जाए। लेकिन हमारी परंपरागत ऊर्जा के जो स्रोत हैं वो समाप्त होते जा को इस बचाने के लिए अगर इस पे हम अच्छे प्रकार से काम नहीं करेंगे तो हमारी मानवता खतरे में पड़ जाएगी, और जब खतरे में पड़ जाएगी हम कोई भी चीज करने की योग्य ही नहीं बचेंगे। इसलिए मानवता को ध्यान में रखते हुए, पर्यावरण को ध्यान में रखते हुए हमें पुनः उस परंपरागत ऊर्जा के स्रोतों को छोड़ करके नए ऊर्जा के संसाधनों पे विचार करना होगा, इस पे काम करना होगा। इसके लिए बहुत ही आवश्यक है कि हमारे इंजीनियरिंग सेक्टर के विद्यार्थियों को, हमारे इंजीनियरिंग सेक्टर के सारे टीचर्स को इसमें आगे आएं और आगे बढ़ करके काम करें और इसको एक नई दिशा दें। पूरा संसार इससे लाभान्वित हो और इसको करने की बहुत जरूरत है। एक बार मैं पुनः AICT को इसके लिए बहुत बहुत धन्यवाद देना चाहता हूं और पूरे टीम को इस KIPM परिवार के तरफ से हम बहुत बहुत शुभकामना और धन्यवाद देते हैं। जय हिंद, जय भारत।
Thank you, sir. Now it gives me an immense pleasure to invite our Honorable Chairman, Sri R.D. Singh sir, to address the gathering and bless us with his insightful thoughts. Sir, your continuous support and encouragement have always been a source of strength for our institution, and we humbly request you to share your valuable thoughts and blessings with us. Thank you, sir.
मैं RD सिंह, चेयरमैन KIPM, आदरणीय मुख्य अतिथि महोदय, मैनेजिंग डायरेक्टर, आदरणीय हमारे जो निदेशक जी हैं जिन्होंने अपनी महत्वपूर्ण भूमिका से ये FDP प्रोग्राम AICT के माध्यम से आपने स्वीकृत कराया। मैं इसके लिए सभी मैकेनिकल इंजीनियरिंग के सभी हेड एवं जो है सभी शिक्षकगण को हार्दिक बधाई देता हूं कि और ब्रांचों से हट करके आपने ये इस ब्रांच से आपने FDP प्रोग्राम स्वीकृत कराया, जिससे आपके साथ साथ KIPM को भी एक अच्छा स्थान मिला। मैं इस सस्टेनेबल एनर्जी में जो आज का टॉपिक है, द रोल ऑफ एडवांस मटेरियल इन नेक्स्ट जनरेशन इंजीनियरिंग, इसके अंतर्गत बहुत ही अब आवश्यक हो गया है कि हमारे शिक्षकगण को इसके बारे में जो है बताया जाए, उनको इसके बारे में जो है डिटेल उनके बारे में डिटेल अध्ययन करना चाहिए, जिससे जो आने वाला भविष्य है, जो हमारे बच्चे हैं, वो इस चीज को समझें और हम ऐसे समाज का जो है हम गठन करें कि पर्यावरण और अन्य जो चीजें आज हमारे लिए चल कर के कष्टदायक हो रही हैं, उनमें इम्प्रूवमेंट आवे। इसके लिए हम सभी शिक्षकों को अनुरोध करता हूं कि इस पर गहन अध्ययन करें और अपने अंदर जो विद्यार्थी हैं उनको भी इसके प्रति सचेत करें और हमारी आप लोगों को इसके लिए बहुत बहुत शुभकामना। और आप लोग आगे भी इस तरह से एफडीपी एआईसीटी से स्वीकृत कराते रहें, इससे हमारे शिक्षकों का, छात्रों का बहुत ही विकास होगा। बहुत बहुत धन्यवाद।
Thank you very much, sir. It's been a great honor to hear from you. Now, it is my honor and privilege to invite our esteemed chief guest for the session, Professor Om Prakash sir from Department of Mechanical Engineering, NIT Patna, who has remarkable contributions to the fields of sustainable energy systems, thermal sciences, and advanced materials that has inspired many young researchers and academicians across the nation. We are truly fortunate to have you with us today to share your valuable insights and experiences. So I humbly request Professor Om Prakash sir to deliver the chief guest address. Sir, I request you to kindly address the gathering. The platform is yours. I request all the participants to keep patience. So there has been some technical issues, and our chief guest will connect us with again soon. So please hold our patience and wait for him to join. Thank you very much. I request our chief guest, Professor Om Prakash sir, to deliver his chief guest address, sir. We are willing to hear from you. Sir, the screen is not visible. I request you to please speak. Sir, your screen is not visible. I request you again to please look for the video screen, sir. The technical setup will hardly take 2 to 5 minutes more. So I request all the participants to please keep the patience. Our chief guest will connect with us soon. There is some technical issues going on. We will recover it as soon as possible.
Can you hear me?
Yes, sir. Yes, sir. Completely
Sorry
audible, sir.
for this
Video is not
disturbance.
visible.
Hello.
Yes, sir. Hello, sir.
हाँ,
Good evening, sir.
कैमरा तो ऑन है?
यस सर सर आपका वीडियो अभी सर डिस्प्ले पे नहीं आ रहा है, आपकी सर आवाज कंप्लीटली ऑडिबल है सर।
अरे आप तो जाओ पीछे उन लोगों को लेके स्पेशल
अच्छा
लेके जाओ।
आपके दो बच्चे हैं,
दो था लेकिन डंडी एक थी।
Now you see,
डंडी के लिए लड़ाई होती है। मेरी बिटिया कह रही है
नहीं वैसे ये अक्सर ऐसा काम करवाते
हाँ?
मेरी बिटिया कह रही है
लड़ाई
तो यहाँ पे तो दिख रहा है।
ऐसी concept है।
अच्छा,
ये तुम मार ऊपर ले जाएगा तो मुझे भी दे देना, तो वो नीचे आएगा।
one minute.
तो मैंने युद्ध साथ किया।
हैं सीन के ना पीछे
Hello. Now you see, video is coming on now.
नो सर वीडियो इज स्टिल नॉट देयर सर।
से डाल दिया गया।
Hello. Please. Now, I think I can start here because I don't know why video is not coming.
Yes sir, no issue sir. For the sir chief guest address we can continue with this sir.
Then we will. Now you can see what is the condition.
Yes sir, so screen is somehow visible, the display is ready.
Okay. I am audible.
Yes sir.
I am very happy to share to see that really the KIPM is growing like anything, and they are hosting that ATAL academic program, and that also they have chosen a very good topic, that is a faculty development towards sustainability, the role of advanced material in the next generation engineering. Really, it's a very good topic, and I think this is a today demand topic, because once you are seeing here how the sustainability can be maintained, you see how we are developing from this age. By taking, if you are seeing here the 3S plus 2 sustainability, then we are seeing that 3S means source is very important. 1S means source. Another one is a storage, that source, how much storage is there. Then this both together we are taking and we are making a system. And from that system, we are again going for the serving the services. Whatever the services is available, that services we are doing through these sources and storage. Now, when you are seeing this today topic, has been so wisely chosen. This topic where we are losing nowadays storage. This storage, what is the high grade of energy is there, high quality of energy is there, that we are today losing, and that we are how we will be able to sustain for the coming generation. For that, this topic is very, very essential for the whole world today. And I think KIPM and KIPM is hosting that one. And I congratulate the engineer R.D. Singh, who is being an engineer, and after that what he has taken and the step, and he has established this institute KIPM, and through that many times I have participated in his institute and seen that how engineers, that means for experimental to the theory, and he has his life itself is shown these things, how it will be converted to the experiment to the theory, or we are that is a experiment to the teaching. And this teaching and learning program really from the government of India, who has hosting basically through the AICT. It's very, very important program. And in this, I congratulate Professor J.P. Pandey, who is a chief patron, and that patron, Engineer R.D. Singh, and chairperson, Mr. Khan Saab, and coordinator Rahul Patel, who is really doing a lot of things to uplift this KIPM. And then also the coordinator, Mr. Gorakhpur, and organizing members, Mr. Shah Fateh and Anuj Shukla, Amit Kumar Singh, and Madhav Kumar Dwivedi, Sailen Singh. I think this jointly they are hosting the things, and with this, a lot of advantage it is going to our faculty members, along with that our researchers who is involved in doing this research. And that challenge we have to take it, and then we have to see different part of that in this. If you are saying which way we are developing now, the challenge is here, whatever storage is there, that we are day to day losing. And when we are losing this, what next it is coming? So that challenge, like earlier age, you can think of that when we are the formation of coal, formation of the oil, and these are all very high grade energy. And then from the high grade energy, we are able to take it, these things for our development. And that development is now, it is again challenging to the system. And that system, again, we have to take out that next system, next generation, which can be sustainable. Otherwise, it's very difficult for our coming generation, how they will be surviving. And this, the sustainability means not only that is the for one direction, it is the whole direction, it is the whole way. That means from the environment, we have to see, from the energy requirement, we have to see, and we have to see again which way we have to go for our requirement. That means what fast growing our trends are there, that we have to maintain. For that, it's very, very important thing. The topic has been chosen in this, and here you can see here the important thing is whenever we are going for that any development, we have to sketch from the that means from the environment. All knowledge is coming from the environment, and that from that environment only we have to see which way we are seeing. And that environment itself is giving many things. I am just sharing one example here. When I am just see whatever our researcher or inventors are there, how they are getting the knowledge, and from that knowledge how they are getting converted into the technology, and that technology is going, and finally it is meeting to our day-to-day requirement. So I think a lot of session is comprises of this. Around 13 sessions are there. In 13 session, all topic, what is the topic is taken, that topic is very, very important topic. I think it's all is covered from the green to the whatever the sustainability means. It's all type of industries what is taking place, that all it is being covered. And I think that this will be the great success, and those who are participating in this faculty development program, they will be getting a lot of advantage in that. And I am thanks to all of you being invited me as a chief guest. And some, because of some problems, I was not able to I am not able to share the things, and that I will be happy to see. And I again congratulate all of you. Thank you. Hello.
Thank you very much, sir. Now I request Assistant Professor from the Mechanical of Department, Mr. Shailen Singh, sir, to share vote of thanks, because we are approaching towards the conclusion of the inaugural session, and it is time for express our gratitude to all those who made this event a success. So to deliver the vote of thanks, I request again Mr. Shailen Singh, sir. The stage is all yours.
Thank you, Anu sir.
Good evening, everyone. Myself, Shailendra Singh, Assistant Professor in Department of Mechanical Engineering at KIPM College of Engineering and Technology, GIDA. First, I would like to express my deepest gratitude to Professor Prakash sir to give his precious time for this faculty development program. It is my honor and privilege to listen to his words of wisdom, which he said, and he truly said that the world is going to change with the help of emerging technologies in the field of sustainable development. I would also like to express my sincere thanks to Director Sir, to our Chief Patron, Engineer R.D. Singh Sir, Coordinator Mr. Rahul Patel Sir, and all the members of organizing committee, distinguished members, and participants who are here to participate in this conference and take away some innovative ideas from this conference, from this faculty development program. As we have listened to our honorable chief guest, director sir, and other distinguished members, we can conclude that the future of the mankind will be defined by the use of advanced material in different areas of application. The rapid changes in technology with the use of advanced materials, nanomaterials, biomaterials, smart material, and advanced alloys are key to innovation in different areas of engineering like aerospace, automobile, energy, robotics, and biomedical engineering. These advanced materials are now transforming the future of engineering by enabling lighter, stronger, and more efficient and sustainable technologies across industries. Thank you very much. Now I welcome you all to participate in this faculty development program so that we can take away some important and very innovative ideas for the future technologies. Thank you very much.
Thank you very much, sir. Now, as we have come to the conclusion of this inaugural session, I would now like to invite all of you to capture this memorable occasion. I kindly request all dignitaries, speakers, and participants to please turn on your cameras for a short duration so that we can join for a quick group photo that will be taken to the online mode. And your presence on screen will help us preserve this wonderful moment as a token of today's successful inauguration. So I request all the participants to please turn on their videos so that a group photo can be taken. Thank you. Thank you, everyone. Now we can all turn off our camera screen so that the connectivity issues do not bother us all. Now let us proceed for today's session and get into the insights of the benefits, the real benefits of the faculty development program that we are going to have. So for the session one, we today have a very eminent speaker, Professor Om Prakash sir. Professor Om Prakash sir is a distinguished professor in the Department of Mechanical Engineering at NIT Patna. His work spans core and emerging areas such as power plant, heat and mass transfer, renewable energy, and internal combustion engines. He is known for combining theoretical modeling, computational simulation, and experimental validation in his research. One of Professor Prakash's notable research interests is in Earth-air heat exchanger. He has published work on a 3D simulation and experimental validation of EAHE systems, which focuses on passive heating and cooling strategies. He has also contributed to the studies on biodiesel from non-edible seed oils and examining engine performance, combustion characteristics, and emissions. Even exploring the use of nano additives such as carbon nanotubes to improve fuel behavior. His portfolio further includes work on the microchannel heat sinks, thermal performance optimization, and energy harvesting technologies. Professor Om Prakash sir is a very prolific personality. He has over 70 published articles and multiple patents credited to his name. At his department, He is also supervised multiple research students, guiding their dissertations and contributing to the academic growth of his peers. He holds a strong reputation for bridging rigor with application. His work is relevant to sustainable systems and cleaner energy technologies. Given the theme of this FDP towards sustainability, the role of advanced materials in next-gen engineering, Sir's expertise is exceptionally well suitable for his contribution today in today's session. His expertise in renewable energy system, heat transfer, environmental impact of the energy systems, and material-based innovations aligns directly with the core challenges in sustainable engineering. By virtue of his deep research experience, he will not only present theoretical insights but also a real experimental case studies and perspectives on future directions. Therefore, as a research person, Professor Om Prakash sir brings us both technical depth as well as the practical relevance, making him an ideal expert to lead session on clean energy materials, life cycle assessment, and multiple more. So, we are all excited to hear from you, sir. The virtual platform is all yours. Thank you, sir.
Hello. Can you listen me?
Yes, sir. Completely audible, sir.
Okay. Thank you. Thank you for good introduction. I am really appreciated. And this all thing is because of students, because of my good students, those who are with me, and they are contributed a lot for me, and it's give me a lot of pleasure. And I here also I am presenting something that is the material for clean energy solar application in Indian perspective. You see, if you are seeing here, always sustainable we are telling, but you know, sustainable means what? That to be think of the first we have to define the sustainability. Sustainability means whatever resource are there, that resource when we are using, and the amount, the resource again to be refilled. That means the resource or the storage, you can say the storage to be taken from the use, and again it should be come to the storage. So then we called as a sustainable. There means if sustainability will be maintained, that means the storage, amount of storage, that to be maintained here. Whatever expenses we are doing and whatever it's coming in that to be fulfilled. So here I am telling you, whatever you just see, some materials, if you are talking like iron, one of the major utilization in the whole our day-to-day activities. In this iron, if you are seeing, so iron is basically coming from where? It is also coming, it is coming from the from the earth itself. If you are seeing this iron formation, so that we are having the hematite, magnetite, like these things in the ore, and from the ore again we are going for the cleaning, and then we are making the iron. And if you are seeing iron, again it is oxidized, and then again it will be coming into the in the form of oxidized, and this will be going back. So you can see here, if you are doing some certainly these things, and if you are going in that aspect, some more things if you are doing, then you are increasing the life of that. So that means here in that direction, what is there? Iron is a one storage in the form of hematite or magnetite, and from there again if you are going and using, and then again it's very difficult, you cannot form the hematite because it is oxidized. So what we have to see? So that means whatever utilization of iron is there or other material is there, similar material is there, that we have to see which way we should utilize for, so that it will be coming generation should be helped. So in that I am seeing here in the form of energy also, basically all source of energy is a solar, and from the solar itself we are taking, and then we are using in the different form of energy. If you are seeing here my next slide, that is the regarding the tamso ma jyotirgamay, darkness to light. it's very, very important thing. And from there only the life came in in the existence, and here we are enjoying the whole world. And if you are seeing, and then the next slide where I have put it, this proverb, in the earth was not given to us by our parents, it has been loaned to us by our children. You can think of here, if you are seeing and if you are thinking in such a way, what for we are here and why this earth is there. If we are thinking this is a loan, so we have to repay the things. That means whatever utilization we are doing, that to be created also. In that case, it will be the safe for our coming generation. That we must protect the earth for our future generation. Now, if you will see here, what I have talked with that in my earlier session, the resource is very, very important. From the resource, if you are seeing what are things is the available on the form of the resource here on the earth. If you will see, there is three things in one, in the bigger way. If you are distributing, then we are seeing here, the one is a lithosphere, another is a hydrosphere, and third one is a atmosphere. If you are all together, we are seeing, and if you will see here, the life is creation of life, or whatever living things are there, that is the where atmosphere, hydrosphere, and lithosphere all together in meeting there only we are. That means the all living creature can be happened. So that means you can think of how this all atmosphere, hydrosphere, and lithosphere is working together and creating a different things, and that among that one we are also one of them. Now, if you are seeing here, the next thing, how we are going for this development. So if you are seeing this development system, so we are producing from this environment, we are taking a very small space, and that space we called where we are looking, and we are getting the all whatever the change is taking place, that change in, and that change what takes place, and the observation of that change we called as a system. So that means from the system to environment we are moving. So that means from this system to environment, and this system when we are creating for fulfillment of our requirement, then we are thinking in many way, what is my requirement is there, and from that requirement to fulfill that requirement we are using this all resources. And so that, and finally when we are creating the system, we are not able to see how much time it is taking, and then it will be affecting our environment, because the environment is very important, and that from that environment only we are living here. So that means from the when we are creating something, and then we are seeing the environment, and that environment, seeing the environment, a lot of time is taking place. Now I am seeing a very simple example. When we are created the IC engine, internal combustion engine, then whatever the exhaust was there, this from the system IC engine, then that was not affected to the environment, because that was so small, and that will be automatically so dissolved, and that we are not able to see. But today what is there, we are seeing this is the one of the biggest challenge on the earth, and now that's why we are looking and seeing, because the development has taken from the fire to wheel, and wheel to the engine. So that development when we are seeing, and this has taken around, you can say around 400 200 years, not 1 year, and then we are seeing the effect. So slowly again we are modifying these things and seeing that what system we should create, and that is the challenge for all coming generation, which way the system should be created so that we can fulfill our requirement, and that do not disturb to our environment. So now if you are seeing here another slide, And this is a very beautiful slide I have taken from the how the this thing is happening. And here, if you are seeing that earlier when we have developed the fire, so then it was a allowable things was a wood, and then again we have to gone into the deep, and then we have created and we have find out the another thing, what is the coal is there. Then further we have gone and then we have created the oil, and then further research we have done. Then we have gone to the natural gas, which is the most important source of energy. Then again we have developed and we have gone for that another step, that is very beautiful step, and that was the nuclear one, where mass and energy both is created, both is exchange. And then now at present, by doing this all thing, again challenge came, and that challenge we are facing nowadays. And then we are seeing that is the clean fuel, and in this clean fuel we are seeing the hydrogen and basically ammonia, where there is no carbon. So that means the beautiful way we are moving. And I'll see, and when there is no carbon, in that case what is there, whatever the ammonia and this hydrogen is there, again it will be forming the water and other things, nitrogen, and then again it will be cycling the things. So that means here the research and the invention, how it is a one by one, it is a challenging to all coming generation, and we are all contributing in that. Now next thing you can see here, the next thing, now the challenge is here, how we can able to balance the lost. You can see the plant, and from that plant we are taking the clean energy, and we are doing that things, we have to balance the things. Now again you can see here the resource, another one is a system, and from the system whatever our requirement is there, that we are fulfilling requirement, and then whatever the thing is coming which we are not able to utilize, that we call as a waste. And that waste, I am sharing one part here. Once in 2007 approximately, I have seen how much energy is there, and that energy, when we are seeing that energy or level is a lot of energy in the form of the low temperature. So then we have seen what way we have to do. So then I have published one paper, that is a waste to energy. And that waste to energy, it's for a really, this is not basically paper, that is the challenge to the society, how the waste can be created to the energy. That means suppose a power plant is a running, and that power plant is a giving some heat, and we are converted into the work. Again work is utilized, again it will be converted into the heat. Basically it is coming into the form of heat, but that heat, what is the heat is being converted, that is very, that temperature is very low, and that is a huge amount. And that low temperature, whatever system by which we have created the work, but at this temperature, that temperature was around 1600 degrees centigrade, 2000 degrees centigrade, around 900 degrees centigrade, in that range of temperature. But here what we are created here, around 30-40 degrees centigrade temperature. It's very difficult now, that 30-40 degrees centigrade temperature. That means we have to create some other system which can be utilized this small differences, and then we can go far ahead. Now you can see here another slide is same in environment. And this environment, again you have see the system and this requirement. That means here you are seeing that whatever things we are coming taking from the environment, again we are processing, and again we are fulfilling our requirement, then again we are throwing into the environment. Now you can see here about our country, because I am my topic itself is a covering that is the sustainable and that material which we are using, and along with that energy what we are using. So that means here in the Indian perspective, if you are saying, then India is a tropical country, and you can say it is a breeze by plenty of sunshine. You can see here, that's why people are telling, many times we are seeing many Americans, they came ki that is the our population is growing like anything. But it's because of the beauty of this, what is the environment, because this is the environment is created, otherwise it's very difficult. That's why I have written here the beach by plenty of sunshine almost all over its surface and throughout the year, and sunshine is captured and transferred to the heat by performing many other processes like drying and other thing. If you are seeing India, really India is a one country who is giving a theoretical knowledge or theory to the whole world. So that's why you see in 1981, when the world was not thinking, that time we thought it, and we have created a commission for additional source of energy. You can think of here in 1981. And then further this commission is being converted into the Department of Non-Conventional Energy Source in 1982 under the Ministry of Energy. And then you see in 1992 Ministry of Non-Conventional Energy Source, and renamed in 2006 Ministry of New and Renewable Energy, Government of India. So now we are the first country in the whole world who has seen what will be the effect is there, and that effects we have realized, and then we have created that new and renewable energy ministry. This is the ministry who is in the world first time it is created by the Indian. Now you see, in the transition of the clean energy is a critical global priority and aim to reducing the greenhouse gases like emission, mitigating the climatic change. As the world seeks sustainable solution, the role of material becomes increasingly and significant. So it is very important. Now we have to see which type of material we should use so that it will consume less energy, and that to be easily available, and then it will be transformed. After transferring, again it will be giving the useful things, and that to be again it will be converted. So in this material are engineered to process unique property, and that enhance the performance in the various application, making them vital in the development of energy and efficient technology. If you are not seeing the material, now you are seeing, if you are some material we are using, and if you see energy point of view, then a lot of energy you utilize, and then we are processing that material and making that material to use for our day-to-day requirement. And that's why we have to choose now the material here for processing which required less energy, and that will available very easily, and that to be sustainability should be there. And that's why this things is very important at today. And that one of these material are, if you are seeing nowadays, we see in every vehicles and everywhere we are seeing that material is basically composite material, and that composite material, if you are seeing, it is being produced from the natural fibers like jute, hemp, coconut, date palm, and then we are making this formally by combining two or more material with the different properties, different हेलो, हाँ मौर्य जी, एक थोड़ा मीटिंग चल रही है, ठीक. So now you see this composite material is formed by the combining two or more material with the different property, and without dissolving as a blend then into each other. And for example, you can say reinforcement concrete and bricks and fiberglass, like these things. When these things are came, now you can see here, when we are using the this iron rod, or you can say another things. And now if you are combining with the concrete, then their life along with that structure stability, that all is increased. So similarly, we are producing and seeing this. If you are seeing the natural fibers, like you have given the topic, very well known topic, I have seen here. That topic is a bamboo as a sustainable alternative to the steel and concrete. Now you can think of that is a session 12. You are going to discuss in that. Also one of your expert lecture is there in that case. So this is the beauty here, how iron we are going for replacing with this bamboo. What is the natural fibers are there from that, and again we are having that that much strength. What is requirement is there. That means in material side we are choosing different things and combining with other things so that we can make this composite one, and that can be able to fulfill the requirement. Now if you are seeing the thermal insulation, hello, हेलो, हाँ नमस्ते, एक मिनट थोड़ी देर में बात करते हैं. हाँ, now if you are seeing here the this fibers, and in this fibers when we are going for insulation and other purpose, the natural fibers is having the low thermal conductivity, making them effective for insulator. For example, flax, hemp fibers, and excellent thermal resistance and contributing to the energy saving in the building and application. Now again you are seeing, if you are seeing the mechanical strength, then natural fibers such as a jute and other things is having high tensile strength and stiffness, which enhance the structural integrity and composite material of the composite material. This mechanical robustness is a crucial for maintaining the insulation performance under the various conditions. So now if you are seeing in the form of the density, so natural fibers typically have the lower density compared to the synthetic fibers, and resulting a lightweight composite, which is the characteristic for advancing for the application where the weight reduction is a priority, such as in the automobile and aerospace also we are seeing. So now you see which way we are moving. If you are renewability and biodegradability, if you are discussing, for which we are basically our topic is there, and basically whole ATAL program is FDP is around this. Then you see here the divert from the plant and natural fibers are renewable and biodegradable, and this reduces the environmental effect, for which we are really, we all are bothered about that, and supporting the sustainable development in practice. So now if you are seeing this all things, so here another by seeing this all things, now we have chosen one experiments, and that is for distillation. And for distillation, mainly whatever the material was used earlier, that all material is being produced from the, what is the basically iron, tin, and many other things are there. But here, if you will see this material which we have already manufactured one of engineering college by one of my student, and that is being manufactured and then it is being tested, and it is given just like a very good result for that. So for example, if you are seeing this material is produced using coconut, date palm, and bamboo fibers, and all together you can see here the coconut fiber. Can you see my this hello? Hello? Can you see this slide?
Yes, sir.
It's clear now?
Yes, sir. It's clear, sir.
Very nice. Good. So now you see that
Yes, sir, it is clear.
Earlier we are using and many other things, right? But in this project or in this renewable things, what we have used, you have used the natural available coconut fibers, bamboo fibers, and date palm fibers, and then we have using the epoxy and other things for hardening as a material. Now you see And the production is, you can see here, which way for frame is there, and this epoxy and hardener we have used, then bamboo fiber we have added in this, then epoxy hardener, then coconut fiber again we have added, and this again it has gone further, then we have made the composite. Now you can see this is the frame by which in figure 5 and 6 you can see we have prepared and this prepared material now we are utilizing here. Now you can see the next slide here, which way we have prepared the handy lay. This is all work is from the PhD work. One of my student who has done this work, and that I am sharing. Now you can see which way it is being cut and then it is being used here, and then further the next slide here it is being treated, and after treatment further it is being compacted, and then after compacting then you can see here it is added so that it will be able to make the things. Then composite sample on composite material, if you are seeing the property here, a beautiful things we have got it here. In the dimension, the bamboo fibers by volume is 20 we have used, and then fiber here around 10%, dead Fallman around 10%, matrix volume around 60%, and you see the thermal conductivity is 0.19 to 0.22 we got it, and water absorptivity is very small, that is 2.1 to 4.5. That means here now I am just from this example I am really very happy to share you all these things. What was the my topic was there, we have to get it the distillate water, because that was the challenge. For getting the distillate water we have to make a the equipment by which we can take out the distillate. So if you are taking the distillate, that means we require the energy, and such that solar energy we required, and that we have used the solar energy, and that solar energy again it will be falling, and then it will be vaporizing, and then again it will be coming in the form of condensing, and then we are producing. So what are the properties required for that equipment, and that for that we have done these all things, making the natural resources, and then we have produced these things, and we have taken the different percentage here so that we can able to get it this which are the property, which property is required, and that which property that tested, and we got it the very good property, like water absorption is very low, thermal conductivity is low because we required the low thermal conductivity, as well the matrix volume is very good. That means whatever the property we required, that property we achieved by that things. Otherwise, mostly all researcher they have used some other material, but here this material is being used so that we can have that property, and that to be sustainable material we have used. Now you can see here the bamboo around 20% and coconut 10%. If you are using like this figure we got it, and then in 9 figures if you would see here, so approximately you can see here the bamboo around 10%, date around 10%, and coconut this type of, and you can see how a beautiful the color is also came because of that natural color of our environmental material or renewable material. Now next slide if you will see here, this is the sample again 15% and coconut, and the once we are seeing this one while sharing this materials and this what we have manufactured, and that's along with the color and other properties what we required that we have achieved. So renewable and biodegradable in nature, if you are seeing the natural fiber such as like this is a resource, and then production of synthetic fiber through this way we are able to get it that things. Now you can see renewability like fossil fuel based on the synthetic fiber, and biodegradability what we have already used low. And now you see energy consumption and emission if you are seeing for this material what we have produced, that is the production and processing of natural fiber composite generally have a lower environmental effect compared to the synthetic alternatives, and that is the key factor. number one thing is a lower energy requirement. There is no energy requirement here. This is the all is we have done, whatever the process we had adopted, this all process we have done at a natural temperature and natural way. So there is a very small energy what is required for cutting another thing, that only we have used. Other is a needed is very small, and that will be the needed for the natural fibers. Now you see reduce carbon footprint. In this you will see, because this is the natural way, and that is the natural what is producing the, which is absorbing the carbon dioxide, and that same thing we have used here. So that there will be no, there will be very small the carbon prints here. The fewer toxic emission. In processing also, if you will see, there is no natural, this natural fibers which don't involve any toxic chemicals emission prepare for the production of synthetic fiber like fiberglass and carbon fibers, which is required a lot of that means emissions. But here there is no such things is happening. Now if you end of the life, if you will see at the disposal point of view, one of the most significant environmental advantage and the natural fiber composite is there, which will be very favorable life, and that will be disposable characteristic which will be there. The biodegradability, if you are seeing the natural fiber which we produce this material, that will be having the very biodegradability under the appreciated conditions and returning valuable nutrient to the soil. Again, the reducing the landfill wastage. This is the stark and contrast of the synthetic composite, which can be persist in the environment of hundreds of years, and there will be no problem for that. Then if you are seeing the composting side, many natural fiber and compostings can be composted at the end of their life cycle and provided the environmentally friendly and disposable option for enhancing the soil quality. So that means again, whatever the nature it is giving, the same natural way we have produced the material which can be used here. If you are seeing recycling, then it is very good natural fiber, and that is recycled and new products. Further, if you are extending the life of cycle, then you are getting the very good cycle in this, as well as technique such as the mechanical grinding and chemical recycling are being developed to the recycling the fibers and matrix material from use of the composite here. Now see, if you are seeing another thing, comparative life cycle assessment, then we are seeing here the natural fiber and composite synthetic composite often reveal the following. For that is the lower global warming potential. It's very low because its carbon footprint is less, and that's why it is there. Then reducing the ecocity of this cultivation and processing of natural fiber, which is typically results the lower ecotoxicity, and this impact of the compared to the production of the synthetic fiber, which involve the more hazardous material, but where we are not at this stage. If you are seeing the energy efficiency point of view, this natural fiber composite usually requires less energy for the production of processing, making them more energy efficient throughout their life cycle. And now you see the natural application for natural fiber, what we have made it that is the natural fiber reinforcement composite material. One of the application for the natural fiber composite, which we are we use for this, basically we produce for the solar distillation purpose, and that we have able to do this thing. And this, you know, this will be produced by the one of the your in engineering college, Rajki Engineering College, that is in Azamgarh, who has done, one of my students who has done these things. Now if you see the all dimension, you can see here, this is all made from that natural fibers here, and this dimension we have taken so that we can have our purpose was basically to produce the distilled water, and that's why from the material side, say from material side to energy side, we have used the way that should be renewable as will be sustainable. That is the main purpose for that, and that's why we have worked in that. And you can see here different measuring and measuring instrument what we have used for anemometer and solarimeter and thermocouple are all used so that we can observe what is happening to the all. Until unless we are not having the observation and observation data is very important for the calculation and comparison for that. So like this, you can see the calculation point of view, what is the global radiation is there, what is the east radiation, west radiation, like this all measurement we have taken. And then what is the amount of water we have get it output from that, so that we can get it how much efficiency is there. So now you can see this observation data for experimental arrangement of the water depth of 1 centimeter, and we have used here cotton wicks so that we can we can enhance the what we call that evaporation, and that's why we have used here the cotton wicks. So if you are seeing this data here, a very beautiful what is the coming here in this case, what is the intensity is there, how much temperature is there, what is the outcome is there. Now you can see here the variation of solar radiation. If you are it is varying, then what amount of radiation, how the radiation is varying along with the number of hours. So you can see here this why this one is the resource. What we have told, this is the resource that is in form of energy, and what is the material we have utilized for the solar distillate. Now this what sustainable or you can say renewable energy we have utilized here for producing the distillate. Now you can see here the temperature, how temperature is increased here, because the ambient temperature how much there, and in that case in distillate how much temperature is there. You can see this is the variation. Now why this variation is there? Because of this the closed one, and there is a conductivity what you have seen earlier, what the property you have seen, that conductivity is very less. Along with that, that's why we are getting the very good this system temperature inside the system. What is the temperature is there? That's basin water temperature. We got it very good temperature. Now you can see here the amount of water what is coming out in the milliliter, and now you can see number of hour what is increasing, and then you can see here the amount of water how it is increasing. That means here that whatever the energy it is falling, and that is a mostly solar energy that is converted into the useful one, and this is coming. Now next thing you see here, in instantaneous efficiency, if you are seeing, that's approximately we have at peak hour around 2 o'clock, around you can say 50% efficiency we are having. That means very good efficiency. Why good efficiency we are having? Because of that material what we have selected, that material. I am going to see here the variation also, the other material what we are using, that one. If you are comparing this material with the other material possibly used for the solar steel, you can see this is aluminum is used. That solar steel is having around hardly you can say 18 to 25% efficiency, whereas the material used steel, if you are seeing another researcher who has used around 18 to 20% efficiency they have noticed, and material which is glass fibers and reinforcement, that is very difficult, and that's a lot of challenges is there in that case, because environmental effect is there. So this will be having around 7 to 8% only. A material used, that is if you are using wood and other because the wood is the compatibility and the life is also there. Because of that life, it's very less life is there, because it is reactive with the water, and that will be having slightly after certain interval of time your that life is very less. So if it is giving around 18%, where you see material of polywood were 7 to 8% only efficiency, and natural fiber what we have produced here, you can see it is getting around 26.15%. So now you can see from this a good things by using that one, by changing the material here itself, and that material same whatever other environmental condition is same, and that it is giving 26.15%, whereas you are seeing around maximum 20% approximately efficiency you are getting from the other one. This is the real challenge what we have got it. Now you can see
Dear participants, there has been some technical issue. Our expert will connect with us in 2 to 5 minutes. Kindly hold the patience. Thank you. While our expert is trying to reconnect, I request all the participants to go to the feedback link and submit it immediately. The expert will connect us with soon. So there is some issue with the audio. The voice is not audible, sir.
यहीं से
अभी देखिए
Yes, sir. The screen is visible and the audio is also clear, sir.
very nice good 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 so now just I am just the first I will be sharing some more things hello ah yeah hello
Yes, sir. There is some issue with the audio, sir.
yes sir yes 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 yes
is still there. So now you can see, yes. Hello. Now you can see, yes, this meditation. Is seeing the chart. Hello. I think again systematic approach. What that Hello.
Yes,
Are you
yes,
able to
sir.
see my slides?
Yes, sir.
Okay. So now you can see the material again we have one. Basically, dimension what we have want to see here. So that is hello.
No audio is coming.
Yes, sir.
It is coming.
Yes, yes.
Your voice is coming.
Yes, sir.
So
Yes, sir. Yes.
Voice is not coming, it's breaking, sir.
references we have taken the calculation here in this case. and different systems we have made from that system, 1, 2, 3, 4, like this system we have generated, and people all of the reason here, and see, system is created by the different things, and you can see the observation by instrument is by putting the major measuring instruments, and that we have created here, and by creation of that you can see here which way make machine and other things are there, and this observation you can able to see. This observation, by that you can see here the result is beautiful things is coming. That is the ambient temperature is how much? Ambient humidity you can see around 53 to 40% is variation is there. And refrigerated temperature you can see here around 5 to 10 degree. And the practical refrigeration you can see this much. So approximately you can see the variation of the coming with this design are creating the small system, and we can able to use that group contains energy as well as natural things for creating which will be not disturbing the system. Now you can see here the temperature and other things that whatever the different system we have created, like this part 1, part 2, part 3, like this, and you can see this is the effect of the temperature is there, and that temperature effect you can see here. So similarly, you can see the temperature effects are ambient, larger and ambient temperature. They are also also we have done. And finally, you can see here, this is the loss of the weight. What is the force loss is there? That is also very minimum in that case. And lastly, I am sharing here, you can see which is not preserved, and that is this you can see the how it is being best, and here you can see which one is the preserved, that has given the good, very good result. This is again you can see cucumber also we have put it in there, and there you can see the not preserved one and preserved one. Lastly, the one can say I am concluding this one because the time is there. Here the challenge what we are getting, that we have to take the challenge and seeing this environmental effect, and then we can able to switch off that thing. With this, I think I should, if any question is there, then that can be shared. Hello?
Thank you very much, sir. I request all the participants, if there is some queries.
Any question, any inquiry? Hello?
Okay, sir. I guess there is no query. So thank you very much, sir. Thank you very much, sir, for your enlightening and deeply insightful lecture on the materials for clean energy solar applications, Indian perspective. Your detailed discussion on the role of natural fiber composites, their fabrication techniques, and life cycle assessment truly broadened our understanding of sustainable material innovation. The way you linked scientific principles with the practical applications, such as the development of solar steel, low cost clay based systems, and the renewable composites, beautifully demonstrate India's potential in advancing clean energy technologies. Your expertise has inspired all of us to explore research pathways that align technology with the environment responsibility. And on the behalf of Mechanical Engineering Department, KIPM College of Engineering and Technology, and all the FDP participants, we extend our heartfelt gratitude for your valuable time, knowledge, and guidance. Thank you once again, sir. Thank you very much, sir. Now, before proceeding for the next session, I request all the participants to take a little break for the 5 minutes, and then we will be back here with our expert for the next session. Thank you. Let's have a break for the 5 minutes and we will join back here again. Thank you for your patience. Thank you, everyone.